Hello friends, in this chapter we will study about sampling method. Before we go further, it is important to know why sampling is done, where it is used. Actually, sampling is a tool used in business and finance. It is an appreciated as well as maligned tool depending upon how it is used. It is basically used to improve our decision making skills. It is used to reduce risk and uncertainty. And here few terms are being described for your better understanding. Actually, sample is the subset of population, and samples and populations are described using mean, median, and mode as well as standard deviation. When we describe sample and population using mean, median, and mode, when these terms are used to describe sample, we call it statistic. And when these terms are used to describe population, is called parameter. Here, look, for population, size is capital N and its mean is mu and standard deviation is sigma. You call it delta or sigma. I will call it sigma. For sample, size is small n, mean is x bar, and standard deviation is small s. These parameters and statistics are very important for numerical purpose. So you are requested to see it again. For population, size is capital N, mean is mu, standard deviation is sigma, and for sample, size is small n, mean is x bar, and standard deviation is small s. Once again, I am repeating, sample is the subset of population. Population is actually a set and sample is the subset of population. Okay. See, mean is average mathematically and it is very simple, you know it. Median is the middle value of distribution. To understand it better, we take two examples. Suppose we are taking a set of 1, 2, 5, 7, 8, 4, 6. Now, after arranging in increasing order, we get 1, 2, 4, 5, 6, 7, 8. 1, 2, 4 and 6, 7, 8. Between them, 5 is the middle value. Okay, so here median is 5. In other set, 1, 5, 2, 8, 7, 2. By arranging it in increasing or decreasing order, we take it in increasing order, we get 1, 2, 2, 5, 7, 8. Now, here we see there is no middle value. 1, 2, 7, 8, 2 and 5. Both are the middle value. Then we take both 2 and 5 and get their average. That is 2 plus 5 divided by 2 is equal to 3.5. This is the median. And mode is nothing but it is the value that occurs more frequently in any data set or distribution. To understand it better, let's take an example. Suppose we take a set 1, 2, 3, 3, 2, 2, 5, 6. Here 2 is occurring more frequently. Here 2 occurs 1, 2, 3 times more than any other figure. So here mode is 2. Okay, standard deviation for population is sigma, and for a sample is small s. Okay, standard deviation represents variation of an entity from its expected value. Okay, here we see one formula of standard deviation of population, that is 1 divided by small n under root sigma x minus mu whole square. Okay, this is the formula of standard deviation of population. We will see how it works in numerical part. Before going further, let's see distribution. In a normal distribution, see this figure looks like an inverted bell. When inverted bell icon we see the distribution is symmetrical. Okay, in normal distribution, mean, mode and median are equal. Again, I am repeating, in normal distribution, in symmetrical distribution, mean, median and mode are equal. It is very important. And when there is a little deviation in normal distribution, that is called skewness. Okay, when there is right skew, that is positive skew, just see the figure, inverted bell, and there is a little shift, little deviation in normal distribution in right direction. Okay, this is right skew, and in second figure there is left skew, that is negative skew. Okay, so in positive skew, in right skew, mean is greater than median is greater than mode, and in left skew, that is in negative skew, mean is less than median is less than mode. These are two very important points. Actually, 3 important points I have given for your objective question, that is in normal distribution, mean, mode and median is equal, and in right skew, that is positive skew, mean is greater than median is greater than mode, and in negative skew or left skew, mean is less than median is less than mode. Okay, now we will see sampling method. Here there are basically 4 types of sampling method: judgmental sampling, biased sampling, random sampling and quota sampling. Quota sampling is actually out of syllabus, but for your kind attention, here quota sampling is being mentioned. Quota sampling is basically used when time is limited. Let's talk about judgmental sampling, biased sampling, random sampling. Judgmental sampling is basically based on someone's judgment. It totally depends upon judgment. On the basis of someone's judgment, we take some sample and we do sampling. Biased sampling is actually based on some kind of survey. Suppose the parliament is debating on women's bill, and you are asked to conduct an opinion survey because women are the most affected by women's bill. You go and interview a lot of women in different cities, towns and rural areas of India. Then you report that an overwhelming 95% are in favor of reservation for women in parliament. So you particularly select one particular sample, that is women, and based on the sampling method, you just get the opinion that most of the women are in favor of women reservation. This is one kind of example of biased sampling. And the most important sampling, that we must focus on is random sampling. Okay, random sampling are of 4 types: simple random, systematic sampling, stratified sampling, and cluster sampling. Simple random sampling is of 2 types, that is with replacement and without replacement. When simple random sampling is done with replacement, then probability remains constant. It is very important. I am repeating again. When simple random sampling is done with replacement, then probability remains constant, and when it is done without replacement, then probability increases, and when it is done without replacement, probability increases. It is very important for your examination point of view. When simple random sampling is done with replacement, probability remains constant, and without replacement, probability increases. In stratified sampling, when we see the word stratified, strata, okay, that means we divide population into strata. Let's see a figure like we divide population into male and female. Male is one strata and female is other strata. So here population is divided into strata in stratified sampling. In cluster sampling, or we can say the block sampling, population is divided into cluster. The basic difference between stratified sampling and cluster sampling is, in stratified sampling, members are homogeneous, and in cluster or block sampling, members are of heterogeneous nature. So this is very important. In stratified sampling, members are homogeneous, and in cluster or block sampling, members are heterogeneous. Now we will see central limit theorem. According to central limit theorem, distribution will be normal if sample size is large. Distribution will be normal if sample size is large. Obviously, when the sample size is large, distribution will be normal. There will be less error, there will be less deviation. So according to central limit theorem, distribution will be normal, sample size is large. Before we look numericals based on sampling method, let's see important formulae, and we will work out using these formulae for numerical standard deviation. Sigma x bar is equal to sigma divided by under root small n. For finite population, this is the formula for sampling fraction. Small n divided by capital N, small n, as you remember, is the sample size, and capital N is population size. And one important formula for your objective purpose, Carl Pearson suggested relationship between mean, median and mode. That is, mean minus mode is equal to mean minus median subtraction 3 times of mean minus median subtraction, or you can say it 2 mean is equal to 3 median minus mode, or 2 mode is equal to 3 median minus mean. You can remember any one of them. That is Carl Pearson suggested relationship between mean, median and mode. This is all for your